Hello student, today we will be solving the IB Math AHL May 2025 paper 3 times on 1 question number 2. You will be getting the solution for the first question from this paper and the solutions to the other questions from other past papers in form of playlists on my channel NS Online Math Tutoring Classes. You will also be getting playlists where the solved past paper questions will be available based on their topics. I'm Nilanjana Sanyal. I'm an online IB Math AHL level tutor. My phone number and my website address are displayed at the bottom of the screen. So without any further delay, let us start to solve this question number 2. The maximum mark is 32. Informally, the curvature of a curve can be thought of as the amount by which the curve deviates from being a straight line. In this question, you will investigate the curvature of a variety of functions. Consider any function f that can be differentiated twice. The curvature, this is actually the Greek letter kappa, but you may call this k. I am calling it k because many students will be having difficulty in recognizing this as kappa. Okay, so k of any function f is defined by k of x equal to f double prime, that is the second derivative of f of x with respect to x and the absolute value of that, divided by 1 plus the first derivative of f of x with respect to x whole squared, and this whole thing is getting raised to the power of 3 over 2. Okay. Consider the family of linear functions g of x equal to mx plus c, where x is a real number and m and c are also real numbers. So part A's question is show that k of x equal to 0 for this family of linear functions. Okay, so we have to get the first derivative and the second derivative. That is why they have said consider any function f that can be differentiated twice. Okay, so g of x equal to mx plus c. Therefore, g prime of x will be equal to m and g double prime of x will be equal to 0. Okay, so therefore, k of x should be equal to absolute value of 0 over 1 plus m squared. F prime x is g prime x, which is m squared, and this is getting raised to the power of 3 over 2. So this should be, the numerator is 0, so this should be equal to 0. Okay, therefore k of x is equal to 0. Shown. Okay, consider the family of quadratic functions h of x equal to ax squared plus bx plus c, where x is a real number, a is a real number, a is not equal to 0, and b and c are also real numbers. For this family of quadratic functions, it is given that k of x, you can find the second derivative and the first derivative, and you can use this expression. You will be seeing the curvature expression is coming to be this one. Okay, but you don't have to do the differentiation. They have given you the curvatures expression k of x and the first derivative of k of x expression. Okay, the maximum value of k of x is denoted by k max. Subpart B, it is having 4 subparts. The subpart I is saying by solving k prime of x equal to 0, find the value of x where k max occurs, and you are not required to justify that this value of x leads to a maximum, because first derivative is equal to 0. That means that value of x will be the x coordinate of a stationary point. It can be corresponding to a local maximum or a local minimum or the stationary point of inflection, but you do not have to justify that that value of x corresponds to the local maximum point. Just we have to find the value of x. So k prime of x is equal to 0 implies we'll be taking this expression 12a times absolute value of a and 2ax plus b over 1 plus 2ax plus b whole square raised to the power of 5 over 2. This is equal to 0. Since they have said that e is not equal to 0, okay? E is not equal to 0. Therefore, 2ax plus b has to be equal to 0, because whenever a fraction is equal to 0, that implies that the numerator of the fraction is equal to 0. And the numerator is 12a times absolute value of a times 2ax plus b. So a is not equal to 0. Therefore, a, or the absolute value of a, they will not be equal to 0. 12 is definitely not equal to 0. So 2ax plus b has to be equal to 0. Okay. So therefore, implies x equal to negative b over 2a. And they have asked us to find the value of x where the k max occurs. So this is the answer. Fine, it carried just a single mark. I determine an expression for k max in terms of a only. Okay, so I k max is equal to, we have to take this expression to an absolute value of a over 1 plus 2a times, in place of x we'll be writing negative b over 2a. So negative b over 2a plus b, this is whole square, and again this whole thing is raised to the power of 3 over 2. Okay, so this is equal to, therefore k max is equal to 2 times absolute value of a, and this is 1, and these two will be getting cancelled. So this will be minus b plus b is 0. So 0 square is 0. So this is 1 plus 0 raised to the power of 3 over 2, and therefore k max 1 raised to the power 1 plus 0 is 1. So 1 raised to the power of 3 over 2 is 1. So k max is equal to 2 times absolute value of a. Subpart I state the value of limit extends to infinity k of x and explain briefly the significance of this result. So let me answer this question over here. Okay, limit extends to infinity and it is k of x is equal to 2 times absolute value of a divided by 1 plus 2ax plus b whole square, and this is getting raised to the power of 3 over 2. And now limit, only this part is having x. So I am isolating this part. So limit extends to infinity 2ax plus b tends to infinity. Okay. So you don't have any limit, it tends to infinity. Or let me write this inverse, tends to infinity. And when the denominator of a fraction, as the denominator of a fraction becomes larger, the fraction value becomes smaller. So this is infinity, 1 plus infinity, it is a really large number in the denominator. So the fraction value will be almost equal to 0, okay? When the denominator is very large, the fraction value is almost equal to 0. Therefore, limit x tends to infinity, k of x is equal to 0. Okay, carrying 2 marks. Fine. Fourth subpart. Consider the quadratic functions p of x equal to negative 2x squared plus 2x minus 10. X is a real number and qx equal to 2x squared plus 5x plus 25. Again, x is a real number. State which one of the following statements is true and justify your answer. So the option A is k max of p is greater than k max of q. Option B is k max of p is less than k max of q. And option C is k max of p is equal to k max of q. Okay. And we have seen that the expression for k max is 2 times absolute value of A. So max of p is equal to 2 times P is minus 2 for P, and absolute value of minus 2 is positive 2. So this is equal to 4. And K max of Q is equal to 2 times, it is 2. Absolute value of 2 is 2, so I am writing 2. This is also equal to 4. Okay. So therefore, the answer is option C, K max of P is equal to K max of Q. Okay. Consider the function v of x equal to ln of x, where x is a real number, x is greater than 0. For v, it is given that k of x equal to x over 1 plus x squared raised to the power of 3 over 2. It is following exactly the expression that is given for k of x. The general expression, the first derivative, absolute value, sorry, the numerator is the absolute value of the second derivative. So divided by 1 plus the first derivative whole square and this raised to the power of 3 over 2. It is exactly the same expression, but depending on what is the function expression, the first derivative or the second derivative's expression will be different. And you don't have to differentiate. They have already given us the expression for the curvature k of x and its first derivative, k prime of x as 1 minus 2x squared over 1 plus x squared raised to the power of 5 over 2. Subpart C is having 2 further subparts. The I is saying determine the exact value of x where k max occurs. And you are not required to justify that this value of x leads to a maximum. Okay, so k max, so first of all, we will be equating the first derivative to 0. So k prime of x is equal to 0 implies 1 minus 2x square over 1 plus x square raised to the power of 5 over 2 equal to 0 implies 1 minus 2x square equal to 0, or 2x square is equal to 1 and x square is equal to half. So therefore x is equal to 1 over root 2 or root 2 over 2, anything, because we are taking the square root and I am writing only the positive square root. Why am I rejecting the negative square root? Because x is greater than 0. It is given x is greater than 0. Okay. One over root 2 is the answer, and if you want to rationalize the denominator, you multiply both the numerator and the denominator by root 2. So it will be 1 times root 2 will be root 2, and root 2 times root 2 is 2. Okay. I show that k max equal to 2 root 3 over 9. So k max is equal to x. Okay, let me first of all write the expression. Actually, k max cannot have the x. I have to take this particular value of x. So first of all, let me write the general expression of k of x. So 1 plus x square raised to the power of 3 over 2. So therefore, k max should be equal to, I am writing 1 over root 2 for x, and it is 1 plus 1 over root 2 whole square, and this whole thing is getting raised to the power of 3 over 2. Okay. So this is equal to 1 over root 2 and 1 plus 1 over root 2 whole square is 1 square is 1 and root 2 square is 2. So it is half raised to the power of 3 over 2. So this is 1 over root 2 is 2 to the power of half divided by 1 plus 3, half is 3 over 2. So 3 over 2 raised to the power of 3 over 2. Okay. Or this can be written as 1 over 2 to the power of half multiplied by 2 over 3 raised to the power of 3 over 2. Okay. So this is equal to 1 over 2 to the power of half times 2 to the power of 3 over 2 over 3 to the power of 3 over 2. So 2 to the power of 3 over 2 divided by 2 to the power of half is 2 to the power of 3 over 2 minus half over 3 to the power of 3 over 2. Okay. So this is equal to 3 over 2 minus half is 1. So this is 2 to the power of 1 or 2. Simply 2. And what is this? This is, if I express this in radical form, it is the square root of 3 cube. Okay. And how do we get the square root? Square root of 3 cube means 3 times 3 times 3. And since it is the square root, we have to pair the numbers and we have to take out 1, 3 from each pair. If we have to rationalize the denominator, then what do we have to do? We have to get another 3 so that we get 2 pairs and we can take out 1, 3 from each pair and we will be getting this 9. So in order to get one more 3 within the square root, we have to multiply both the numerator and the denominator by root 3. So this is equal to 2 root 3 over 9. Okay, because as soon as I'm multiplying this square root of 3 cube with square root of 3, I'm getting 4 3's within the square root under the square root, and so that I can get 2 pairs of 3's and I'll be taking out 1 3 from each pair. Okay, so therefore K max is equal to 2 root 3 over 9. Okay, and fine. So we are done with Sapat C. Now we come to Sapat D. Consider the function w of x equal to e to the power of x, where x is a real number. For w, it is given that k of x equal to e to the power of x over 1 plus 2x whole raised to the power of 3 over 2. And the first derivative of k of x is e to the power of x times 1 minus 2 times e to the power of 2x divided by 1 plus 2x whole raised to the power of 5 over 2. And I show that k max equal to 2 root 3 over 9. So first of all, we have to get the value of x, for which k of x is maximum, and then we have to substitute that value. So let me solve this Sapat D over here. So first derivative of k of x is equal to 0, implies e to the power of x and 1 minus 2 e to the power of 2x over 1 plus e to the power of 2x raised to the power of 5 over 2 equal to 0, implies e to the power of x and 1 minus 2 e to the power of 2x is equal to 0. Okay, since if you just try to recollect the graph of e to the power of x, how does it look like? It is this: the x-axis is the horizontal asymptote, and this is the y-intercept, it is 1. So e to the power of x can never be equal to 0. It will not be meeting the x-axis or touching the x-axis for any value of x. So this e to the power of x will never be equal to 0. Therefore, 1 minus 2 e to the power of 2x is equal to 0, implies 2 e to the power of 2x is equal to 1, or e to the power of 2x is equal to half, implies, and taking ln of both the sides, so 2x is equal to ln of half, and it is carrying 5 marks. So x is equal to half ln of half, which can be written as ln of half raised to the power of half. So therefore, x equal to ln of 1 raised to the power of half is 1, and 2 raised to the power of half is root 2. So 1 over root 2. Okay. So now we have to substitute this value of x in this case expression, so that to find the value of k max. Okay. So therefore, k max is equal to e to the power of ln of 1 over root 2 over 1 plus e to the power of 2 times ln of 1 over root 2 and whole raised to the power of 3 over 2. Okay. So this is equal to e to the power of ln of 1 over root 2 is 1 over root 2. Okay. And this one, the denominator, is 1 plus e to the power of 2 times ln of 1 over root 2 can be written as ln of 1 over root 2 whole square. Okay. You have to play, you have to know how to play with these, the e and ln, and this one is the coefficient. You take it to the power position. Sometimes you bring the power down to the coefficient place. You have to be very good in doing these modifications. Okay. So this is this, and so this is equal to 1 over root 2 divided by, now e and ln, they are inverse function, they will be cancelling. So 1 plus 1 over root 2 whole square is half raised to the power of 3 over 2. And you see, for the previous thing also when we had ln. This also was equal to, I can write this as 1 over 2 to the power of half, and 1 plus half is 3 over 2, raised to the power of 3 over 2. So this is 3 over 2 raised to the power of 3 over 2. See, it is exactly the same. 1 over 2 raised to the power of half divided by 3 over 2 raised to the power of 3 over 2. Okay? So therefore, it is equal to 1 over 2 to the power of half times 2 to the power of 3 over 2 divided by 3 to the power of 3 over 2. Therefore, you can write K max. I'm not going into the details because the calculation will be exactly the same. You can leave the details because you have shown this part, this calculation portion. Okay. So it will be 2 root 3 over 9. Okay. So this is shown. Okay. I suggest a reason why V and W have the same K max. This was V ln of x and this is W. K max for ln of x and this is W e to the power of x K max. Okay. So why do they have the same value for K max? And it is carrying just a single mark. Okay, so because ln of x and e to the power of x, they are just inverse functions. If you try to think about their graphs, e to the power of x is like this. E to the power of x, the horizontal asymptote is the x-axis, and for the ln of x, the vertical asymptote will be the y-axis, and it will be this way. This is ln of x curve, and these two are the inverse functions of each other because if you see the graphs, these two, one is the mirror reflection of the other on this line y equal to x. If you place a mirror on this line y equal to x, then one will be the mirror reflection of the other. Okay. So since e to the power of x and ln of x are inverse functions, therefore their graphs will be the mirror reflection of each other when the mirror will be placed on the y equal to x line. Okay. So therefore, their curvatures are the same. So K max of V is equal to K max of W. Okay. Fine. We have given the answer for DII. consider a family of curves y equal to square root of r square minus x square, where x is greater than negative r but is less than positive r, y is greater than 0, and r is a positive constant. E is subpart E is also having two further subparts. Subpart I is saying that show that d2y by dx square equal to minus r square over y cube. Okay, and it is carrying 6 marks. Fine. So E, let me write the expression first. Y equal to square root of r square minus x square, and r is greater than 0 and y is also greater than 0. Fine, and this can be written as, therefore y is equal to r square minus x square whole raised to the power of half, because I have to differentiate and I cannot differentiate keeping the radical sign. So we have to find the second derivative. First of all, we will be finding the first derivative. So dy by dx, I am differentiating this expression directly, but if you cannot differentiate it in one step, this is a composite function, then you can write let p is equal to r square minus x square. I know majority of the students will be able to differentiate in one step. In case you have any confusion, you can use the chain rule, and y will be equal to p to the power of half. And you need dy by dx, so dy by dx should be equal to dy by dp times dp by dx. Okay, so you can use this method also, but I am differentiating it directly, so it will be half, the power will be coming down, and power gets reduced by 1, so half minus 1 is minus half, and then the derivative of r square minus x square, r square it is a constant, so minus x square, so the derivative will be minus 2x, and these two will be cancelling, so this is equal to minus x over square root of r square minus x square, or you can write or minus x over y, because square root of r square over minus x square is y. Okay, so this is the dy by dx. Okay, and now we have to find the expression for the second derivative. Now you can take the first derivative's expression as this one or this one, anything. And obviously for both of them you have to use the quotient rule. If you want, I can show the differentiation of both the expressions. Okay, so method 1, I'll be taking this one. It is u is negative x and v is square root of r square minus x square. So d2y by dx square should be equal to, the denominator will be v square, so v is square root of r square minus x square, so v square will be just r square minus x square, and it will be u prime v, so u prime will be negative 1, u is negative x, so u prime is negative 1 times v and minus u v prime, and v prime is the derivative of square root of r square minus x square, which is this y, and we have found the derivative, it is dy by dx. So I'll be just writing this expression, I'll be copying this expression directly. So minus x over square root of r square minus x square. Okay, so this is equal to minus square root of r square minus x square. I'm writing the denominator, and it is minus of minus x is plus x times minus x is minus x square. So minus x square over square root of r square minus x square. Okay, so this is the numerator times 1 over r square minus x square. This is the denominator, okay? So this is, I'll be making the common denominator as square root of r square minus x square. So this is r square minus x square, and this multiplied with this will be giving us simple r square minus x square. So it is minus r square minus x square and then minus x square from this one, and times by 1 over r square minus x square. Okay, and this is what, if you open the brackets, it will be minus r square plus x square minus x square. So plus x square and minus x square will be cancelling, and you will be having minus r square in the numerator. And what is the denominator? This one is r square minus x square whole raised to the power of half times by r square minus x square. So what will be the denominator? If you are confused, again you can substitute. Let a equal to r square minus x square. So therefore it will be square root of r square minus x square can be written as r square minus x square raised to the power of half, or it is a to the power of half times this one is a. So the product will be a to the power of half plus 1, which is a to the power of 3 over 2. So it will be r square minus x square raised to the power of 3 over 2. Okay. Okay, I'm not taking this one, the radical sign right now. It is r square minus x square raised to the power of 3 over 2. Okay, and but I have to come to this expression minus r square over y cube. So I can write this as minus r square over r square minus x square whole raised to the power of half, and this is getting raised to the power of 3. Okay, it is 3 over 2. I have written it in this way, and this part is nothing but y. So therefore d2y by dx square is equal to minus r square over y cube. Okay, shown. So I have showed the expression for d2y by dx square, the second derivative, as minus r square over y cube, taking the first expression. And now I will be taking this one, minus x over y. We have to use the implicit differentiation in this case. Okay. So method 2. dy by dx is equal to minus x over y. Okay. So therefore d2y by dx square equal to the denominator, v is equal to y, so the denominator will be v square or y square, and the numerator is u prime v, u prime is negative 1 times v is y, and minus u v prime. So minus of minus x, u is minus x, and v prime, v is y, so v prime will be 1 dx, so it is dy, 1 dy dx, so it is dy by dx. Okay, so this is equal to minus y plus x, and what is dy by dx? It is minus x over y. So minus x over y times 1 over y square. So this is, again I am taking the common denominator as y. So this term will become minus y square, and this is minus x square times 1 over y square. So the denominator is simply y cube, y times y square is y cube, and the numerator is minus y square plus x square, right? But we know y equal to square root of r square minus x square. So if we square both the sides, we get y square equal to r square minus x square. So y square plus x square should be equal to r square. So in place of y square plus x square, we can write r square. So this is minus r square over y cube. This is the expression for d2y by dx square. Okay. Shown. Fine. Now, I hence showed that the curvature k is constant for this family of curves. We have to bring in the expression for k of x. Okay, it is carrying 5 marks. I. So this is the expression. If double prime of x is equal to this one, minus r square over y cube, and if prime of x was equal to minus x over y. See? Minus x over y. Okay? And of course, r is greater than 0 and y is greater than 0. So therefore, k of x is equal to the absolute value of minus r square over y cube divided by 1 plus minus x over y whole square and raised to the power of 3 over 2. Okay. So this is equal to absolute value. So it is r square because r is greater than 0 and y is greater than 0. So r square over y cube times 1 over 1 plus x square over y square whole raised to the power of 3 over 2. So this is equal to r square over y cube times 1 over y square plus x square over y square whole raised to the power of 3 over 2. Okay, and y square plus x square is r square. So this is r square over y cube times 1 over r square, and just separating the numerator and the denominator. So it is r square raised to the power of 3 over 2 divided by y square raised to the power of 3 over 2. I can do that because a over b raised to the power of m is equal to a over m divided by b over m. Okay. So these two will be getting cancelled and these two will be getting cancelled. And you are having, if you consider just this part, it is 1 divided by r cube over y cube. Okay. So this will be 1 multiplied by y cube over r cube. So this is equal to r square over y cube times y cube over r cube. So these two will be getting cancelled and you have this. This is k of x, the curvature. So therefore, k of x equal to 1 over r, positive constant. R is greater than 0, a positive constant. So 1 over r will also be greater than 0, a positive constant. Shown. So we have completed solving this question. Thank you for staying with me till the end. Please like and share this video in case you have liked my explanation, and please subscribe to my YouTube channel in case you have not subscribed to my channel till now. Your liking, sharing and subscribing will be really helping me. In our next session, we'll be starting to solve a new paper. Till then, bye.